Hey guys, this is a sort of two-part video. We haven't done any videos for quite a while. My shop is most of the time not far from zero, sometimes below zero, and I'm at the back end of some flu, which hasn't exactly made me enthusiastic about any machining, even if I could get in there. Anyway, it occurred to me just to give you a little bit of interest. This device here, some people may have seen it, some shooters may have even seen it or have it. It's called an accurizer. It's made by a guy called Paco Kelly, and his website is pacotools.com. He makes several shooting oriented tools. His standard of machining is superb. I'm not going to spend too long on this because it probably deserves a complete video, so if anybody wants a totally detailed description, just let me know and we'll cover it in another video. Suffice it to say, it is for reforming the 22 caliber bullets. I was going to say 22LR, in fact. Not only 22LR, but the 222 short can also be utilized. Quite simply, a round is placed in one end or the other. There's a tooth-hour difference between each end. I won't go into huge detail on the reasons for that, but the basic principle is you put a round in the end below the periphery. It then has to go on a hard surface, and we've got three tools that can be used. The principle is whichever tool you're using goes into that, and it is then hit either with this is a very hard rubber mallet or hammer. Slightly better is a hard plastic nylon hammer, and it's given a fairly sharp blow, and that deforms the top of the bullet. However, the disadvantage, that's a pretty slow process at the best of times, but one of the main problems is consistency of impact between the hammer and the tool to get a consistent result. So to that end, it seemed useful to have a special tool. So that is what I'm basically going to show you. Well, here is the tool, which is actually very simple. There are only three actual components, but basic components. We've got a base which is 4 by about 3 by 4. Not going to worry, these measurements are not critical. So anybody who wants to make one of these, it's a question of digging through your scrap and seeing what you've got. So you need a base, and the center here is machined out, and there's a disc of tape, which is just a very slight softening, and the device goes in the middle, and the particular round goes, let me just put, so I'll put a round nose in the 224 end. The other end is 222. I won't go into all the details of that. So we have it sitting ready, and put in one of the tools. This is the prime tool for producing a slight flattening of the head. And the next thing that we require is a weight, and this is as usual, tend to forget dimensions. This is basically 4 by 1.5 by 1. Again, non-critical. It weighs about 1.5 pounds. This is a rubber disc, piece of inner tube, and that doesn't exactly substitute for a plastic hammer, but to avoid steel on brass contact, we just have that as a slight buffer. These verticals are 5/8 round bar, 15 inches tall, and one of them is marked. You won't see the marks actually because they're just Sharpie marks. I haven't got round to engraving them, but from about here we've got 1-inch divisions all the way up. Gives us about 9 or 10 options. I think you can see where we're going here. This is going to have to drop from a certain distance. This on the top is a slight lash up. I've got a proper cross piece, I don't know where it is, but there's just a bolt here and a piece of material which we slide out of the way to let it drop. So we'll say in this instance we're going to drop all the way on the bullet to create a fairly significant flat, which is almost good enough to act as a wad cutter to give a nice clean hole in the paper target. So we'll turn that round and ready for a drop. This table, by the way, is not very level. Alright. We just knocked the round out, and I've got several examples of formed bullets. We'll do a set of close-ups as a separate entity. So just to sum it up, base, 2 parallels, a very heavy weight. I did do the math sometime, which gave me the basic kinetic energy for each dropping point. In the end, the best thing is to do a set of tests, make some notes. Again, I can't find any of those, but the beauty of it is that your drops are consistent. You're not trying to use a plastic hammer at exactly the same impact each time, however close you think it is. This, however, is about as close as you can get if you use the same mark every time. Or these incidentally are threaded, and well, there's not much to see on the bottom. You can just see there are 2 projecting ends of the threads. So as a machining operation, it's fairly simple. Probably the hardest part is machining to the accuracy of, or sufficient accuracy to get these parallel. Very difficult to get slight run out or run in. So I would say that 5/8 is the minimum for rigidity. 3/4 would do as well. Very important to face off the bottom there behind the thread. And this block was finely fitted with a very slight relief to one of the holes, which means once you've got a little bit of easement on those, it slides pretty freely. Okay, there we are. That's all there is to it, and I'm now going to just set up a sequence of close-ups just for interest's sake. To reiterate, if anybody wants a lot of detail of this accurizer, it's called, I'll do a separate video. There are about 3 videos on YouTube which do cover this. If you put in a search for Paco Kelly, you'll find them, but I could go into detail sufficient to make quite an interesting study of it. The main reason though here is just making this tool device. There is the accurizer. As you can see, the standard of machining is extremely good. The 4 dots indicate 224 for the bore size, and this end is 222. I won't go into the whys and wherefores of which you use for what, but there you can see that's nicely made. Now the 3 punch tools, shall we call them, I think this might be a bit overexposed because the background's so dark. Anyway, that is the initial forming tool, which can be used on its own to make a wad cutter. That is called Nasty Nose, which is quite an amusing name. That generates a hollow nose, hollow point, and this one is, I forget what it's called. It actually produces a different type of hollow point which has different characteristics. And here is a test set that was done a long time ago. We start off with the normal untreated round nose, and then we go through increasing drop heights all the way through and finish up with, I think that was a full height drop single impact, which is approximating a wad cutter. You can actually go further by another drop. So that's just a sample effect there. That's the regular round nose. That is the wad cutter with a, that's formed by a double impact, full height. That is the normal hollow point, which has been created by a drop of the slightly round nose tool from full height, followed by a half height nasty nose, the pointed end piece which gives the hollow point. This is the special hollow point, which is reckoned to have rather interesting expansion characteristics. In all cases, the treatment brings the bullets to uniform caliber and therefore potentially more consistent accuracy. And pretty much last but not least, there's no point in coming in close on the drop tool. This is just a closer look at the weight, which, as you said, has got a rubber buffer. It's a piece of tire in a tube. The whole thing's 1.5 pounds weight. And then at the moment I've got this rather temporary setup. I've got a proper thing I made somewhere. That's just a 6mm screw bolt. That's where we put it for a drop, and that's where we put it to park it at the top whilst we set up down at the bottom. Alright guys, there you are. Just a little bit of different something to look at. Alright, thanks for watching.